Alright, so in the last video we saw that Lambda expressions are treated like nested blocks. So they're within the enclosing block scope. So what that should mean is that we're able to use the local variable I. So let's print its value to the console from within the Lambda just to see that this is the case. So I'm going to put something just below the first line's output, and we'll do print line I in the Lambda expression equals plus I. And if we run this, so you can see that the code works fine. So currently I isn't declared as final, as you can see on line 100. So let's actually go ahead and change its value to see what happens. And run it again. Now the moment we do so, IntelliJ then complains about the use of I within the Lambda expression. And any local variable we want to use from the enclosing block has to be effectively final, for the same reason that local variables have to be declared final if we want to use them within an anonymous class's code. By effectively final, I mean that the variable has to be either declared final or its value must never change. Alright, so what about variables that we define inside the Lambda expression? Now the parameters are an example of this. Do you think we can use S1 and S2 outside the Lambda in the enclosing block? Let's actually try that. So outside of the Lambda block, say down here, we put something like S1 equals hello. And no, we can't do this. You can see IntelliJ is complaining. So when working with Lambdas, just imagine the code is enclosed within curly braces. And just to be clear, I'm going to just type a bit of code to show you what the scoping would be. And I'm just going to remove these other things that were causing errors. So just imagine that this is what's actually going on. So we'd start with something like int j equals 0. That's obviously in the wrong place. So put that before the return. Let's just put it up here because we're going to delete this. It's only sort of a temporary thing just to make the point. Alright, so within the code block, string S1, string S2, then whatever our results were in up here. So I can just copy those few lines, paste them into here. So when working with Lambdas, just imagine the code is sort of similar to this, and I'll make that I a j there. That's essentially the scoping. Now, this isn't entirely accurate. The two parameters aren't local variables, and we don't want to return from the entire method. The return statement is returning the result of the Lambda expression. But seeing the Lambda this way helps us with scope, I think, and it's clear that S1 and S2 won't be available to the code outside the Lambda block. So when working with Lambdas, if we want to use the local variables declared in the enclosing block, they have to be effectively final so that the runtime will know what values to use when the Lambda expression is evaluated. So to drive this point home, I'm just going to type in a bit more code. And I'm just going to delete what I added here just to avoid any complications. And let's just add another method which hopefully should make it clear. So public void print value int number equals 25, runnable r equals 2 parentheses because there's no parameters, the arrow token, and then a code block. Then within the code block we're going to put a try, then we'll put a thread.sleep 5000 for 5 seconds, we'll catch interrupted exception, e.print stack trace if there is an error thrown, and then after the exception, so if there's no exception, the value is plus number. That should be runnable R, not E. And we'll put a semicolon at the end of the runnable here, at the end of the close off the code block, complete the code block. Then we'll put new thread r.start. Alright, so in this code we're using a Lambda for a runnable. When the code runs, the thread will sleep for 5 seconds and then print the value of the number variable. Now when the thread is sleeping, the print value method will continue to execute and will exit. And that means that by the time the thread gets around to printing the number, the local variable will no longer exist. So what will the thread print? Well, since any variables in the lambdas are set when the lambda is processed by the runtime, and those values of those variables won't change because they're effectively final, the runtime knows it can use the value of 25, and that's because that was the value of number when it processed the lambda. So in larger applications, quite a bit of time may elapse between creating a runnable and actually using it. So hopefully now you get the point that because lambdas may not be immediately evaluated, any variables that we use within them from outside the lambda must be final. Now we can change variables declared inside the lambda because those variables are within the lambda's scope and so can't be changed outside the lambda. Also, they won't go away because the execution of the enclosing scope has completed. And as in our case of our print value method, where the method will finish executing before the lambda runs. Alright, so let's actually try one more thing. So we're going to add a lambda expression to the enhanced for loop in the main method. And for every employee, we're going to start a thread that prints out their age. So let's go up and do that. So we're going to go back up to the main method, all the way at the top here. I'm just going to clear off some of this now because we've got sort of copies of a lot of this in the previous videos where we've been working on the same code. Let's just clean this up a little bit. Alright, so we've got our employees defined, as you can see on there. So let's add that enhanced for. So we're going to put for employees. We're going to print out employee dot get name. So I forgot to put the variable there for the type, so employee, that should be. It's better. Then we can do get name. So print out the employee name there, and then we're going to create this new thread using a lambda. So it's going to be a new thread with no parameters, but we're going to use parentheses there, arrow token, and then print out employee dot get age dot start. Alright, so let's actually run that and see what it does. Confirm that it works. And you can see that that works. So IntelliJ doesn't complain, and we can run the code successfully, and we can see the age is printed in the console, but obviously it's sporadic times, not necessarily in the same order. So if we just run this again, you can see we're getting different ordering each time we're running it, and that's because the thread's going to be running at different times. So you might be thinking at this point, well, hang on, wait a minute. The employee variable is declared outside the lambda, and its value does change. Doesn't it have to be effectively final to be used within the lambda? Well, the answer to that is yes, it does. And in this case, the employee variable is effectively final. Now, when using an enhanced for loop, a new local variable is created for each iteration of the loop. And that means that the variable is effectively final for each iteration. And if we use instead an old style for loop, we can see this more clearly. So let's just do that. Alright, so it's going to be for, using the old style loop, so it's going to be for int equals I equals 0. Then it's going to be I less than employees dot size I++. Then we're going to do employee equals employees dot get I. Then we're going to print out the employee name using the dot get name method. And then we're going to do a new thread, no parameters, so empty parameter list, arrow token, and print out employee dot get age dot start. And I'll just print something here that's a separator between both of them. And we'll run this. So you can see obviously that worked as well. But you can now see using the old style for loop that it's clear that on each iteration a new employee variable is created, and as a result it's effectively final. So it's assigned once and then never changes. Now if we move the declaration of the employee variable outside the for loop, then it won't be effectively final, and at that point we wouldn't be able to use it. So what I mean by that is just changing this code here, putting employee, and changing this to employee. And we don't get any warnings or errors from IntelliJ, but when we go to run it, we see that we actually get an error and we get this problem about it, the Lambda expression must be final or effectively final. So I'm guessing that IntelliJ's on-the-fly parser doesn't pick up every error of this type. Sometimes we need to run it to actually get these errors to pop up. Alright, before we close this lecture, let's go back to using an enhanced for loop to print the employee name and ages again. So I'm just going to comment out this other code here now. I'll leave the code that we originally had in there. Now, using Lambda expressions, we can actually do better than this. We're printing the ages in another thread to demonstrate a point. Let's just print the ages in the current thread now. So what I'm going to do is just change this here for now, and I'm just going to put leave that first print in there, and change the next one and just put employee dot get age. And get rid of the thread altogether. That's going to just execute it now, and that should obviously work. Nothing particularly unique about that. Now, when Lambda expressions were introduced in Java 8, a bunch of other features were also introduced that made use of Lambdas. And we're going to take a closer look at these features in upcoming videos. For now though, let's have a quick look at a new method in the iterable interface. Now when we iterate, when we're iterating over a collection, as we are here, we can use a Lambda expression and the new iterable.forEach method. Now the forEach method takes a Lambda expression and evaluates it for each item in the iterable collection. So let's update our code that we've got on line 21 to 24 to use a Lambda to print the names and ages. We're going to replace the for loop with the following. So I'm just going to comment that out actually. It'll be the easiest thing to show you this. So we're going to put employees dot forEach. Then we're going to do employee, arrow token, and we're going to add a code block. Then in the code block, we're just going to print employee dot get name and print out the age. Employee dot get age. Like so, and just confirm that it works. And we've obviously got that working as well. So we can see that we're getting the names and ages printed just as we did before. But there's a lot actually going on under the covers when this statement is executed. And we're going to take a closer look at what is going on in the next video on the java.util.function package, which was introduced in Java 8 and contains a bunch of functional interfaces meant to be used with Lambda expressions. So now that we've actually seen Lambda expressions, how have they actually enhanced Java? Well, some developers see Lambdas as nothing more than a syntactic sugar, a more convenient and concise way of writing anonymous classes. I mean, after all, they don't actually add anything to the language that wasn't already there. Now, we can assign them to variables and pass them around, but I mean, we can do that with anonymous class objects as well. Now, other people say that Lambdas are Java's first step into functional programming, which is a programming paradigm that focuses on computing and returning results. And just for more information about functional programming, there's a good Wikipedia article here, a Wikipedia page to be more concise, to be more accurate, and I'll paste that in there. So check out that to find out a bit more about functional programming. At the end of the day though, you'll really have to make your own mind up about how significant you think Lambda expressions really are. But before we move on though, it is important to note that we never have to use a Lambda expression. And in place for Lambda expression, we can always use an anonymous class, and some developers prefer to do so. Now, some Lambda expressions can be difficult to read and understand, especially when you didn't write them yourself. Now, even if you don't intend to use them, it is important to know about them and how they work, because you might have to work on someone else's code at some point, and they may have used Lambda expressions. And also, it is possible that future enhancements to Java might bring features that require the use of Lambda expressions. But right now, whether to use them or not is up to each developer or an employer's coding standard for that matter. Alright, so that concludes our introduction to Lambda expressions. Next we're going to start taking a look at the java.util.function package. So going back to our code, Keep this project open though, the Lambdas project, because we're going to be copying some code from it in the next video. So I'll see you in the next video.